Happy Sunday, friends. Welcome to Bee Spice. In this session, we'll focus on Mastering Alarm Session 12, wherein the important topic, alarm suppression. So, alarm suppression in the sense, what are all the topics we are going to cover in this is bulk suppression, logical suppression, implementation of suppression, and few example of bulk suppression and also logical suppression. So these are the aspects we are going to focus. Let's just get started directly with the alarm suppression. What is this suppression? Suppression is nothing but masking is a function activated by the alarm system to assist the operators to handle alarms. As simple as that. So why we are doing suppression can reduce standing alarms from processes or equipment that is shut down or from process in an abnormal condition. The principle is to hide or mask alarms which no longer have any value to the operator and which may cause the operator to miss alarms which do have value. Okay. So there are two general categories of suppression. As I said earlier, bulk and logical. Okay. So suppression techniques result in alarm signal from equipment being assessed as not appropriate for display to the operator. So that is the point. So they can be very valuable, but should be applied with care. That is also we need to focus. So safety problems have arisen from inappropriate use of suppression. So if we don't do it properly, then that will also backfire. In some cases, use of suppression may be designed to reduce the alarm priority, okay, rather than eliminating the alarm together. In some cases, okay. So whatever approach we are taking, suppressed alarm should still be recorded as a events. That is the summary I want to put forth. Now I'll get on with the bulk suppression. As you know, friends, bulk suppression masks a large number of alarms in one operation and may require manual intervention and authorization to initiate the activation. Okay, so bulk suppression means mask the large number of alarms. Okay, so there are four main approaches. Let's see one by one. So one is the maintenance shutdown suppression. See, suppression of alarms on plant undergoing a maintenance shutdown. So the unit should be physically isolated, inventory free, and suppression should be implemented under a management of change system. What is that? That is AMOC. Okay. So this is about the maintenance. Basically, what is happening here is that equipment will be physically isolated. Yeah? So all these we can bulk do it as a bulk because during maintenance, what's the point in getting alarms, right? So that's the thing. Then operational shutdown process is offline here, but inventory is still held within. Okay, so that is there. So this action may require supervisor authorization. We need to get authorization from the higher authority. So it may be activated by the BPCS if it detects certain measure criteria which confirm that the plant or the unit is shut down. Okay, so BPS can also automatically remove the suppression if its shutdown criteria are not maintained or it may be removed manually. So this is the other kind of a bulb operational shutdown. Then third is the operating mode suppression. See, in operating mode suppression, certain alarms are only relevant in particular process operating modes. For example, shutting down, starting up, or yeah, steady operation or specific batch stages. So suppression can be particularly useful when a process is in a transition mode because it can be a time of high workload when irrelevant alarms are of a particular distraction. You got it, friends? So this is the operating mode suppression. Okay. So this suppression is useful when a process is in a transition mode. See, it's going to be, starting up, it's going to be shutting down. So that time, there are a lot of alarms will come actually. So that and all will distract the people. So that option is also there. We can do that. Okay. Then major event suppression. Typically, the greatest alarm load is after a process upset, isn't it? So which is also very stressful for the operator and potentially hazardous. So many of alarms occurring after a major upset will relate to events that are expected to happen, right? For example, take a case of if a total plant shutdown is initiated, there will be a much intertripping of plants items, and many parameters will go outside the normal operating ranges, which is very normal, right? So suppressing these expected alarms offers significant benefit, especially especially if it allows the expected action that did not occur to be identified. Okay, for example, in a nuclear reactor during the normal operation, an alarm may be required if any rod becomes fully inserted into the reactor. After a trip, an alarm indicating that a control rod has not been fully inserted will be far more important, right? So that is how this is during a major event suppression. So bulk suppression should be clearly displayed to the operator so that it is obvious that these alarms are not functional. That is the point. So this is one way of doing bulk suppression. Okay, right. Then other aspect is a logical suppression. Logical suppression will automatically mask a small number of alarms, even sometimes one, okay, using a agreed criteria. We need to define it. The suppression will automatically remove once the criteria are no longer true. That is the point. So here we don't have to intervene manually. So let's see what are all the approaches. One is there are three basically. So one is a consequential alarm suppression. See, these are for alarms would inevitably occur following a trip of an equipment or an operator action. For example, consequence of stopping a pump may be a low pressure or flow alarm, isn't it? Right. That is a consequence. Yeah? Of course, I'm going to, explain with the example also in the subsequent slides. Second is a redundancy logic. Often, multiple measurements are made of the same process variable. Like generated by different system or used for majority voting in a safety system. So this logic ensures that only a single alarm is displayed to the operator and duplicates are suppressed. Okay. Yeah. So this is the redundancy. Then eclipsing. Eclipsing is a bit, okay, I'll explain this. If a high alarm is present on the same measurement range as a high alarm, then high alarm can be suppressed when the high alarm occurs. So that is the point, friends, eclipsing. So I again repeat, if a high alarm is present on the same measurement range as high alarm, then the high alarm can be suppressed when the high alarm occurs because it's already high is there, right? Why you need to have this? That will, automatically suppress. We have to, of course, put the logic. So this only applies if both are configured as alarm only. Okay. For example, if the high activates a trip, it should not normally be an alarm. So yeah, maybe because it does not require operator action because it's already trips, right? So eclipsing will reduce the number of standing alarms on the list display. But may not necessarily reduce the number of alarms the operator has to accept. So in the list, it will disappear. That is the thing. Okay. Okay. Now we will see the implementation of alarms. I mean suppression. Okay. Uh, See, this one I'm going to give like whether the suppression is automatic or operator initiated. This will give a overall view. So the status of suppress alarm should be very clear to the operator. So that is the intent. Okay. In HMI, you should be able to see. Also, all suppressed alarms should be listed in a report that is readily available to the operator and can be referred to routinely, including a shift handover. Okay. So let's see here types of suppression. As I said earlier, maintenance, operational, operating mode, major event, and logical. Right? Yes, maintenance shutdown is operator initiated. Yes, so it is under management of change. Automatically activated? No, it will not. Automatically reset? No, it will not. Operational shutdown, yes, operator initiated, automatically activated, permissive only. Yes, automatically it will reset actually. Once it become normal, then it will become, reset. Then operating mode, yes, it is optional. This is also optional. This is automatically reset. Major event, it's not an operator initiated, is automatically activated and automatically reset. And logical suppression, no. And this is automatically activated and automatically reset. Okay. So this will give, like what do you call the suppression, whether it's automatic or operator initiated. Just an example, actually. I mean, to give an overview. And one point I want to tell you, friends, during the design, we should actually, do the suppression configuration. For existing system, it should be only added within the framework of the MOC. Okay. The potential effect of the proposed schemes should be assessed to ensure that there are no scenarios where suppression would hide the situation from operator that may require the response. Okay. So, however, the assessment should not be overly pessimistic. That is also we need to focus because failing to suppress can result in regular irritation, which creates its own issue. Okay. Right. What else I can talk here? So let's go this. Yeah, I think I will go directly to the example now. Yeah, example of a specific example of bulk alarm suppression. Bulk alarm suppression. This one I'm using a condition equation, for example, friends. Okay. For example, here we have taken example of a small number of points of a cryogenic unit, which would allow operational shutdown suppression. Okay. Provided these points are below the value shown or in alarm state, then suppression can be enabled. Okay. Anyway, I'll just go into this. For example, your case, this is a one unit. So basically suppression type is unit shutdown. Okay. So if this tag 89H0106.op less than 1%, okay, or if this guy less than 500 nm cube per hour and this guy less than zero point 0.5 bar and this guy equal to alarm, okay, and this guy equal to alarm, so and this guy equal to alarm. So likewise we can actually set, that is what I meant here actually. I don't know whether you're following. So this is particular to one unit. So I'm chosen all the tags actually. If this guy or this guy and all this, okay, satisfies this condition, this is the state. This is the state. Okay. So we can, for example, if 89HC0106.op is less than 1%, then you don't have to, display this. It will go. Likewise, 89FI0107 less than 500, that will also be masked, bulk masked. Like this, friends. Right. Got it? Right. So that is about the bulk. Then we go into the logical suppression. Logical suppression is very, I didn't have any, write up here, but I will explain here. Consider a case, two machines installed, one duty and one standby. You know better, so that's why I didn't put it anything, but I'll try to explain. One duty and one standby. So source, take a source, machine A stopped and machine B stopped. Okay. So the suppression now, stop command A and stop command B. Okay. Just visualize, friends, two machines install, one duty and one standby. So source, machine A stopped and machine B also stopped. So the suppression is stop command A and stop command B. Okay, now I'll explain. If the machine have been tripped by the BPCS, commands to the machines are automatically set to stop, which inhibit the machine stopped alarm. So that is the point. Again, I repeat, if machines have been tripped by the BPCS control system, commands to the machines are automatically set to stop, which inhibits the machine stopped alarm. It's already tripped, right? So what's the point of having this machine stopped alarm? So that is the point, logical suppression. Okay, right. Then with two machines, the second of which is automatically started upon loss of the first. So your time delay is configured to allow time for the second machine to start. For example, 5 seconds before a fail to start alarm is initiated. This is very usual, right? We can do this. Again, I repeat, with two machines, the second of which automatically started on loss of first, a time delay is configured to allow time for the second machine to start 5 seconds before a failed to start alarm is initiated. Okay, so that is the one example. Then pump suction vessel low level. For example, low level LSL can be suppressed when the pump is actually stopped or being commanded to stop, right? So pump is already stopped, then why you need to have this? So you can do this. If a low level is installed as alarm only, no trip action, it can eclipse the LSL. Okay, that is one point. Another point is LSLL, okay, which trips the pump should not normally be an alarm. Okay, if an alarm is justified, it can be suppressed on unit shutdown or the pump has been stopped. The alarm has been present for 20 minutes or tripped by a first failure device. I don't know whether you are getting it. So the point is LSLL, which trips the pump already. Okay, so should not normally be an alert. Okay, because sorry, should not be normally an alarm. It may be an alert because if the alarm is already justified, it can be suppressed on a unit shutdown after the pump has been stopped. Then what is the point in having this, right? So that is the thing. Okay. Then eclipsing actually, eclipsing is nothing but, for example, I'm telling there are successive limits, alarm limits, thresholds basically. For example, high, and low, right? The second level of the alarm meaning high priority, right? Most urgent one can eclipse the first alarm, okay? Less urgent. So, for example, low priority alarm. So that's what I meant. For example, in this case, LSH eclipses an LSH and an LSLL eclipses an LSL. So that's all, friends. I think it's very simple, logical, right? So hope you got some insights. Thanks for watching and keep supporting. Yes. So see you in another topic wherein I will cover on topics about avoiding repeat alarms, how to avoid repeating alarms. Of course, many more are coming up. It all depends on your support. Let's see how it goes. Thank you. Take care. Bye bye.